Hello, teachers, and welcome to Teachers Help Teachers. I'm your host, Esther Yun, and today with me is Alicia Jackson. Alicia Jackson, good morning. Hello.
Good morning. Good morning, everyone.
And Alicia Jackson joins us. She is a facilitator and coach. She works with UCLA Math Project throughout the year. And she also works for Culver City Unified School District as a full-time district level coach. And she also works closely with LAUSD. That's how I met her, actually. There's a summer training, and CGI was offered, specifically planning with the framework and CGI in mind. And that's how I met Alicia. And I have to tell you, if you can find her and go to her training, do it. Because I said to Alicia in the chat room, because we're all Zooming for these trainings, I don't want to leave at the end. That's how terrific Alicia is and how terrific her team was. They're knowledgeable, but more than that, just so self-aware. Alicia, I was blown away by how self-aware, empathetic, knowledgeable, inviting, just everything that makes a facilitator so welcoming. And in that way, teachers, we go there with all these different attitudes of, I don't want to be here, but I have to be here, or I want to be here, but I'm tired, or whatnot. What you did was you really made it so welcoming and fun, and also in the end, ultimately, I learned so much about CGI. So thank you so much for being here.
Oh, thank you. My pleasure.
And on that note, what is CGI?
So first, good morning, everyone. So CGI is short for Cognitively Guided Instruction, and it is a mathematics framework that has been in existence for over 30 years. It's a framework of mathematical practices in which student thinking is at the center of this practice, and teachers prompt or provide stories in which the students are in the center of those stories, different types of math warm-ups and routines where student thinking is what guides our next steps that we take mathematically.
Thank you. And let's take a look at CGI principles then. Those points that Alicia just shared are laid out in these principles. So let's take a look at that. Audience, if you can just pause right here at this point to read through at your pace the CGI principles, that'd be great. This would be the time to pause to read through it. And now, Alicia, having gone through these principles, you shared this with us every day throughout the 4-day training. Will you speak to us about this, how CGI principles really is a shift in instruction from a teacher-led, where the teacher is in front of the class speaking out about math ideas and concepts and addressing the standards, to, like you said, a student-led, student-centered type of instruction. Will you speak on that?
Absolutely. Thank you, Esther. So we now know, because Common Core has changed the way we teach, that our goal is to develop students who are based in process learning, able to analyze their process, able to reflect. We're preparing students for the 21st century, for jobs that don't even exist. Mm-hmm. So with that in mind, as you look at the CGI principles, we realize that students come to class already knowing something about math. We use math daily. So in this way, we look at and help students look at the fact that you're already a mathematician. You already bring a lot of knowledge to school with you. And our job now is actually to facilitate, instead of thinking that we're pouring knowledge into students, we need to look at, well, what knowledge do they have? If we pose a problem or a story to them, what do they already know? And how can we help facilitate even them extending their learning based on what we see students do? And so much of that is us helping students finally help them develop math identity through the space that we provide to allow them to show us what they already know.
And speaking of math identity, CGI consists of standards of different math problem types. That's something teachers must really grapple with, and know like the back of their hand. But it's also strategies, right? So these strategies are entry points, like you mentioned earlier, where students use these strategies to solve problems, right? So will you speak on, when you say strategies, will you speak on those examples? I'm sharing a photo here, and I labeled the strategies and then gave examples of them. Can you tell us more about what we might see students do when they solve problems?
So first, Esther, thank you so much for bringing up the story problem types. The story problem types that you'll see in CGI are very similar, if not almost the same, as the ones that you see in the mathematics framework. Mm-hmm. So what CGI has done with those types of story problem types are the various problems that we'll see throughout our lives mathematically when we're solving word problems. So if we look at the sample we have of 8 plus 5, imagine it's a story that's connected to something that's interesting to students. So it may be Esther has 8 stickers and Alicia gives her 5 more. How many stickers does Esther have now? Mm-hmm. So with that knowledge in mind, the student can already picture themselves actually doing the action of the story. So based on that action, you may see kids do a variety of strategies, and here's 3 samples. So a student who direct models is drawing out every part. So if Esther is direct modeling, she is drawing out her 8 and then drawing out the 5 more, and then she may tell us how she counted. So she may circle that 5 and 5, or she might just start at 8 and count on. So at some point, she may get to a point where she feels like, I don't have to direct model this anymore. I'm using a counting strategy where I just have 8 in my head and I'm going to count on from there. So that's the second example of the counting strategy, where a student might show that to us in a variety of ways. And then the last one, as kids become more sophisticated in how they work out a problem, they might start doing something called an invented algorithm, where they may flexibly break apart a number and do that in their head to solve. So if we ask our student, well, how did you know 8 plus 5 is 13? Esther might say, well, I knew that I could take the 5 out of the 8 and do 5 plus 5 is 10, and then 3 more is 13. So kids will kind of grapple and go back and forth using these kind of strategies, depending on the number sets and the complexity of the problem they're given.
So as a teacher then, if we're seeing a student using this preferred strategy of direct modeling, would something that we say to ourselves about that student, their next progression would be a counting on strategy? Is that something we would say as teachers?
That's something you would look for, right? Depending on the number set. Okay. So as the numbers get more difficult, they may go back to a direct model strategy. Our end goal is that they can solve it, mm-hmm. Right? The difference in the strategy shows us the level of comfort they have with the numbers they're using. So over time, yes, like if eight plus five by the end of the year, you don't want them to still be direct modeling. That is the hope, because then but also that tells you something about the student.
Mhm.
And usually over time, because you've created this community where kids are sharing their thinking, they start to kind of mimic each other. So
Mhm.
over time, someone doesn't want a direct model anymore. If I know that, Esther has stopped direct modeling, she's moved on to something else, I might try that. So it's very experimental and creating that environment where kids are just learning from each other throughout the school year.
Yeah, and I'm listening to you talk about CGI and how just naturally we're just going back to those 7 principles of CGI. I'm hearing examples of that through our dialogue. That's terrific. So last question, Alicia. Someone in our 4-day training said that CGI, in a nutshell, is a way to teach math, and our standards, our domain and standards, are what we need to teach. So, how is CGI the most effective way to teach math?
Thank you, Esther, for asking that. I think it's the most effective way because CGI allows multiple entry points for all students. And when I say that, it means that you have a variety of ways to introduce information to kids through a variety of different types of activities you could be doing. You could be doing math warm-ups I know that in LAUSD, you've been doing counting collections. You've been doing warm-ups like how many ways to make. You've been doing warm-ups.
Number talks.
Yes,
Mhm.
yes. And you're doing your number talks. So you're doing all of that and you're using a variety of different numbers so that all kids have an entryway to solve a problem. Um, and you're also using stories and setups and the way you're doing a workshop model that allows all kids to feel comfortable with sharing their knowledge. They're learning how to speak in ways that also addresses our SMPs, our standard mathematical practices. So just by doing CGI, you're meeting so many things so that you don't have to feel like you have to check it off within one lesson. You'll see a variety of strategies and a variety of I guess you could say, the skill set we want kids to develop just in one session.
And in our next episode, teachers, I've invited 2 other teachers who've implemented CGI for several years now, and they're going to give us concrete examples of of CGI in their daily math routine, and I can't wait to share that. So we've established the content of CGI, what it is, with Alicia, and then in the next episode we'll see it implemented, and I can't wait to share that with you, audience. And Alicia, thank you so much for speaking to us, sharing your knowledge about CGI and its effectiveness. It's, to me, arguably the way to teach math. And I have to say, it's CGI instruction has brought me into the 21st century teaching, and it's helped cultivate my students to be 21st century learners. So thank you again for this wealth of knowledge.
Thank you for having me, Esther, and thank you for this platform of providing this kind of knowledge for your colleagues. It's amazing.
Thank you, my pleasure. So teachers, join me again on the next episode on Teachers Help Teachers, and you have a good day. Thank you. Bye.
Bye.